Okay, welcome to Let's Get to the Marks. Today I'm going through a chemistry A-level walkthrough for a question from the 2023 paper 2 paper. It's on the rate equation. So A and B react together in the presence of an acid catalyst. A aqueous, 2B aqueous goes to C aqueous, D aqueous. The rate equation for the reaction is rate equals K, B to the power of 2, hydrogen ion concentration. So table 1 shows how the values of the relative initial rate vary with the different concentrations of each reagent at the same temperature. Complete the table by calculating the missing values for 3 marks. So we've got experiment 1, 2, 3, 4, and along the top here we've got the different reactants. So we've got A, B, and hydrogen ions. We've also got the relative initial rate at the end. Okay, and we can see there's some gaps there. So our first thing to fill out is in experiment 2. You can see we need to fill out the relative initial rate. So what do we need to do? Well, we need to look at the rate equation and see what has changed. So the relative initial rate was 1. Now we can see that B and H have stayed the same. As you would do in these experiments, you only change one reactant at a time, and the reactant they've changed is A. It's gone from 0.4 mole per decimeter to 0.5 mole per decimeter. But notice that A does not appear in the rate equation. And that the rule tells us if a reactant doesn't appear in the rate equation, we can see there's no A in the rate equation, it doesn't affect the rate of reaction. And so as B and H, which do appear in the rate equation, haven't changed, the relative initial rate is going to be identical. It's still going to be 1. So the rate is 1. They've changed A, but it has no effect on rate. Now let's look at experiment 3. We can see A is 0.4, H hasn't changed, but the rate has changed, which tells me that B must have changed. B appears in the rate equation. So we need to find out what B is. How are we going to find out what B is? So the first step into finding out the concentration of B is we're going to need to solve the rate equation to find K, because we can't find B without K. So let's rearrange the rate equation to find what K is. So here's the rearrangement. We're going to take rate, divide it by B to the power of 2, or B squared, times the hydrogen ion concentration, and that will give us K. So we know that the rate is 1 for experiment 3. We know that, for experiment 1, we're doing this to find K, so we want to either use experiment 1 or experiment 2. So we're going to do 1 over 0.20 squared multiplied by 0.10. And we use experiment 1 or 2 to find K because we have all the data. And so we can see that K is going to be 250. So K is 250. Now, we've found K, but we still can't fill it out. We can now rearrange the equation a second time to make B the subject. And from that, we can use our 250 for K and our 0.64, 0.1, and 0.4, all the other data we have, to work out what B is. So rearrange the rate equation to find B. We're going to do rate this time over K times the hydrogen ion concentration, and that is going to give us B squared. However, we want to square root both sides to get rid of the square, and then we'll find B. So we want the square root of the rate of K over K times H. We know that the rate for experiment 3 is 0.64, so the rate's gone down. We know that K is 250 for all of these, so we're going to do 250 times 0.1, which is the concentration of H, and that is going to give us B if we square root it. So let's whack that in the calculator and work that out. 0.64 over 250 times 0.1 square root. Make sure you use brackets in all of this, as you won't get the right answer. B is equal to 0.16. Boom! We picked up our second mark. Awesome. So, hope you're liking the video. Take the time now to quickly hit the like button. It helps my channel massively and helps me make a video. I'm trying to make a video every single day at the moment. All right, let's move on. Keep moving on, keep moving on, keep moving on, keep moving on. Finally, just plonk the data. This is for the final question in experiment 4 to find the relative initial rate. It's the easiest one of the lot because we're just using the rate equation in its pure form. Rate equals K multiplied by B squared times H. So just plonk that data in and let's see what we get. So we're going to do 250 times 0.3 squared, or 0.30 squared, same thing, times 0.06. And 250 times 0.30 squared times 0.6 is going to give you an answer of 1.35. And that is the relative initial rate. And that is going to score you all 3 marks. So 1 for getting the 1.00, 1 for the 0.16, and 1 for the 1.35. Don't forget to smash the like, share, subscribe. Let's move on to the final part of the question. Okay, for 2.2, a suggested mechanism for the reaction is shown. Step 1, B plus H goes to BH. Step 2, BH plus B goes to B2H. Or step 3, B2H plus A goes to C plus D. Deduce the rate determining step for this reaction. That's the slowest step in the reaction, the rate determining step, the one that limits the rate of the reaction. So it's the one that takes the longest. Give a reason for your answer. Well, you need to know this rule off by heart, and that's that all the reactants in the rate equation must appear in the rate determining step, and they must appear in the same amounts by the end of that step as they do in the equation. So if you can remember the equation from above, we should be looking for the reactants that are in the rate equation. Now, they can be derivatives of the reactants. So it could be like B2H2 would be fine. So it can be something that contains those. All right, let's have a little whip up to that rate equation. If you can look at this rate equation, it's K and B2H. So there should only be B and H in the rate equation, which means step 3, step 3's got A, C, and D. They don't appear in the rate equation, so they're not our rate determining step. Okay. We would look at step 1 and 2 and say these look like they're going to be the rate determining step, and the actual answer is step 2. Why? Because if we look at the rate equation, that it was B squared, or B, 2 lots of B and 1 lot of H, and that's the same amounts that we see here in step 2. Step 1 doesn't have the correct amounts. It has the correct elements, ions, reactants, but not in the right amounts to appear as the rate determining step. God, I'm waffling. All right, guys, that's the end of the video. So once again, subscribe, share, hit the like, all that stuff. I'll see you soon. Let's get to the marks.
You're still here? It's over.